Bismillahirrahmanirrahim. Hello every single person. This is a new video about continuous function, more precisely about uniformly continuous function. So here we give a function, we define a function by the mean of a functional relation equation. So let us get started. Let a be a real number positive, and let f be a function from R into R, continuous function, and it satisfies this equation, functional equation, f of x plus a equal to 1/2 plus the square root of f of x minus f square of x for all x in R. Show that f is uniformly continuous. First of all, we can remark that to be defined this function, it should verify that f of x minus a f square of x should be greater than or equal to 0. This question to make sense to the square root. So this is equivalent to say that f of x times 1 minus f of x, this is greater than or equal to 0 for all x in R. This is 1. The second remark, so here we have possibilities to get positivity, but the second remark is that f of x plus a, this is equal to 1/2 plus the square root of f minus f square. This is positive and 1/2 is positive. This means that f is positive for all x in R. X plus a, we can make a change of variable. We can say that f of x. So f of x is greater than or equal to 0, since it is defined by this relation. From this f is greater than or equal to f of x is greater than or equal, more precisely, 1/2. Why? Because this 1/2 and this is positive. And f of x, since this is positive, so 1 minus f of x should be greater than 0. This means that 1 is greater than f of x. This is less than or equal to 1. Here we have a remark. F is continuous. F is continuous. And f is bounded. But this cannot imply that f is mandatory, is necessarily uniformly continuous. This is not true. To be sure, we can propose this function f from R into R, such that for x it associates sine exponential x. This is a well-known function which is continuous, bounded, but it is not uniformly continuous. Here we verify that this function is bounded by 1/2 and 1, but we cannot say that it is uniformly continuous. Our hope here is to try to prove that f is periodic. If f is periodic, we will have continuity and periodicity, and this is well known, and we prove it in previous video that this function is necessarily a uniformly continuous one. So let us try to prove that this is a periodic function. Here we have two ways to prove that f is uniformly continuous. The first way is to calculate after trying in private situations. F of x plus, we add once again a. So this is equal to f of x plus, I prefer to put here a to a. F of x plus 2a, a is positive. This is equal to f of x plus a. This will be denoted by y plus a. Using this formula, this is equal to 1 over 2 plus the square root of f of y, I mean f of a x plus a, minus f of x plus a square, which is equal to 1/2 the square root. F of x plus y, it is equal to 1/2 plus the square root of f of x minus f square of x. We applied this formula for f of x plus y minus here. We have f of x plus a square. This means 1/2 plus the square root of f of x minus f square of x, all this square. We get equal to 1/2 plus square root of this one, 1/2 plus the square root of f of x minus f square x minus, and here we have 1 over 4 plus 1 over 4 plus with times, so the square root of f of x minus f square of x plus f of x minus f square of x. And here we close the brace. This is equal to 1/2, 1 over f, the square root of all this. Here what we have 1/2 minus 1 over 4. This is equal to 1 over 4. So this is okay with minus. We have the square root of f minus f square minus the square root of f minus f squared. So this will be constant. And we have minus f, so minus f here, minus f of x plus f square of x. This is equal to 1/2 plus, here we have the square root. This is actually f of x minus 1/2 square. Let us verify. This is f square minus f of x plus 1 over 4, and which is equal to 1/2 plus the square root of this function. This means f of x minus 1 over which is equal to f of x for all x in R. This means that f is 2a periodic and continuous means that it is uniformly continuous. This is the quiet way. Suppose that we are not able to do with this easy way. So the second way, basic one, we start from f of x plus a, this one. We can write it equal to 1/2 plus the square root of f of x minus f square of x for all x in a. And here we can write this equal to 1/2 plus the square root of f of x. We write f of x minus a plus a minus f square of x minus a plus a. So we use a change of variable and we applied our formula once again. This will be equal to 1/2 plus the square root of this. It will be what? It will be 1/2 plus the square root of f of x minus a minus f square of what? Of x minus a. Here, don't forget that x and a, x plus a belongs to R, so we have no problem if we take off or if we add. Minus f square, this means that 1/2 plus 1/2 the square root of f square means this, f of x minus a minus f square of x minus a, and all this is taken power square. We repeat the same thing that we did previously, just a few minutes before, and we will get this equation for all x in R. So we have f of x plus a equal to f of x minus a for all x in R. This means that our function is periodic with period to a. If we can make a change of variable to deduce that it is in the standard form. This finishes this video. Thank you very much. See you soon.